All right. Well, it's a little after 11 a.m. in the East Coast of the US, and I'd like to invite everyone for joining our webinar today. It is going to be focused on DirectConnect. This is the new feature in the Eaglet Eye Surface Profiler that directly connects you via your eye surface profiler with the lab of your choice to make it faster and easier to transmit the data. Our host and master of ceremonies today will be Dr. Tom Arnold. I think many of you know Tom. Tom practices in Houston, Texas at the Memorial Eye Center. So also joining us today will be Rainer Storteller, our head of professional affairs, chief R&D guy, software writer, et cetera, algorithm guru, et cetera, et cetera. He'll be joining us with a little bit dive into the Eaglet side of DirectConnect. Alyssa Masler and Troy Miller will be joining us from AccuLens to go over DirectConnect from their standpoint, from the AccuLens standpoint. Sean Blanchard and Richard Dorer will be are here now, I believe, and they will be going through the OneFit side of their fitting tool. And we'll finish up with Christine Sint and Naomi Anderson to talk about their side of DirectConnect with ScanFit Pro. I will turn the deck over to Tom Arnold and let him go through the agenda and what we're going to try and accomplish today. Tom.
Well, thank you, Tom, and welcome to all our guest speakers. Thank you for joining me, and of course, all of you who are attending from literally all over the world. So this is a quick overview of what we're going to cover today. I'm going to talk for a few minutes about why we're here, why this is worth your time. And as Tom said, we're going to go through each of the vendors here today, and they'll explain how they use the data gathered from the eye surface profiler to help design the right lens for your patients. We're going to talk a little bit more in depth about the eye surface profiler, how it works, and then we'll have time for questions and answers. So really looking forward to this, and thanks for joining us. So why are we all here today? Well, we hope in the next 30 minutes or so to show you how the eye surface profiler by Eaglet can really speed up the specialty fitting process. And those of you who are fitting specialty lenses, especially scleral lenses, know that it's time consuming to gather all the data, select the lens, do the over refraction. And so this is a wonderful tool to help speed that process and make it more efficient. We can improve your fitting and help you improve your fitting thanks to the precision of the eye surface profiler. We can take a very good map out to 20 or even 22 millimeters in every direction. These data are not extrapolated, they're real data, they're true data, and very, very visual. And we have a variety of maps will give you the information you need to start fitting your lenses. And even for those of you who have been fitting lenses for a while and feel like you're proficient, and I'm sure you are, technology helps you differentiate yourself from other practitioners and other fitters. There's always that wow factor of having something new and different. And you'll see with some of the maps that we'll be showing you today, especially the bisphere elevation maps, the 3D maps, really helps you bring home to the patient, what a complex case it is and why. And in your hands, in your office, as a specialty fitter, you're the right one to meet their needs and fit them. So there's a certain wow factor to this that we can't ignore. And then the other thing for people who are new and are just getting their feet wet with scleral lenses, it really decreases your learning curve because it takes a while. There's some papers out there that say it takes about 60 fits before you really start being comfortable with this. But think about if you could cut that time in half or even by a third. It would really help you. So it really helps put the right lens on the patient the first time, increases your throughput, decreases chair time, and really helps that patient experience the wow factor that scleral lenses can provide for them. And so how does this happen? Well, the eye surface profiler, it uses fluorophotometry. It has a twin camera system. But the real core of it and the real benefit of the Eaglet eye surface profiler is that it will suggest to you the best design for whichever lens that you choose to fit. And you'll see that there are many different laboratories and many different designs that are embedded within the algorithms of the ESP. So with a better fit, you have improved comfort, you have a happier patient with a very much improved outcome. For technicians, it's easy to use. It focuses itself. It's a very short learning curve. So any of your techs who are familiar with any of your other instrumentation, like your topographer or an OCT or a camera, can really get on board with this with a very short learning curve. And as I said, there's over 40 lenses embedded within the first fit algorithms from over 18 labs, and more being added every day. So chances are whatever lenses you're comfortable with, the Eaglet can give you that first best fit diagnostic lens. Here's just a few of the labs that the eye surface profiler works with, 3 of which are here with us today. We'll explain how they use the DirectConnect feature to pull these data into their fitting guides and designs. So I'm sure many of these names are familiar to most of you. And so chances are whatever lens that you're currently working with, the Eaglet has it already on board for you. So it's an open platform. We're working on all the leading labs. And as I said, we're adding different labs, new labs all the time. So I think with that, we're going to turn it over to Rainer, who really has done a tremendous job, along with Arnie, of perfecting this instrument. And in the last couple of years, I can tell you from working with him, it's really come a long, long way. And so this instrument now is the workhorse in my office, and every new scleral patient gets scanned with the eye surface profiler. So take it away, Rainer.
Usually I'm here telling about all the maps, the numbers, and how you transfer the numbers to fitting algorithms, what we call first lens fit. Right now, I try to keep my part really short, because what we are in the end, what we're aiming for is just click, 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 and you have been designing the back surface of your lens. Of course, in reality, I will always tell you, check the data, check the map, check the quality of your data, but we're aiming for just designing it with a couple of clicks. So let me show why it is so important to have the eye surface profiler data. And I'm showing it right now on the screen. What I've been preparing is I'm looking at the bisphere elevation map, and I did select a chord length of 16 millimeters. Automatically at that moment you get the difference. The difference gives you the largest difference between the flat and the steep meridian 90 degrees apart from each other. In this example, 760 microns. Imagine that you have to get there with your trial set. Most of the trial sets I'm familiar with do have 100, 200 microns of toricity. What I used to do when I was working with sclerals myself, I took 100 micron steps, maybe 200 micron steps, but you're definitely not going from the trial set, that lens, the trial lens having 100 microns to 700 microns at once. So getting there will take you a couple of orders before that you have a good fitting landing zone. So I believe that this really shows why it is so important to have the data. So this is probably the most important. We have a lot of maps. Usually I talk about the quality of the data, but it's basically very simple. You need to have enough coverage. We can measure it 20 by 20 millimeters. You notice horizontally, we have even more than 20. And in this example, vertically, it's 18, which is good enough. So how does it work? After that, you have been checking all your data. So you have been going through the bisphere map, you have been checking the tangent angles map. You simply go over to first lens fit, because that's what we're aiming for. Just a couple of mouse clicks and you have been designing a lens. So how does it work? You select one of the labs you want to work with. So right now, let me show the 3 labs we are working with today. So Blanchard. Let's say that you go for the one fit mat. You select the lens diameter you want to work with. You may have a quick look at the HVID at the bottom right. May help you to select the diameter. So let's say in this example, you want to go with a 16. You hit calculate, and after 20 to 30 seconds, the first calculation is coming up. So give it a little moment. After this, it's very simple. You only have to click this button. So one fit mat fitting tool. From here on, later on, this will be discussed with Richard Dorer, but for now, it's just in our software, you click, it takes you to their website where you can do all the specific parameters which are available for the one fit mat. Similar, we can also do it with ScanFit Pro. So you simply select ScanFit Pro, you hit the button, and all the information is transferred to their fitting tool. At last, we also have to show, of course, AccuLens. So you have the option between Maxim, which is for irregular eyes, and you have Easy Fit, which is for regular eyes. So you choose a Maxim in this example. Once more, have a quick look at the HVID. So it's over 12. Let's say that you want a bigger design. And once more, you hit calculate. AccuLens, the algorithm predicts which lens do you have to take from your trial set. They recommend put this one on eye, do your over refraction, and hit the DirectConnect button, and all the data is pushed into a form, so populated into a form. You fill in your account number, extra features that you want, and also from here on, AccuLens will tell you how it works. That's basically what I wanted to tell today. So we have all the data. So if you want to talk about numbers, please find me. When you want more information about lab-specific features, please find the lab, the consultant. They know much more about it than I do. So from here on, I will hand it over to Tom.
So I think next we're going to actually the labs themselves, starting with Alyssa and Troy from AccuLens.
Okay, terrific. I think everyone should see that. My name is Alyssa, and I am the VP of Sales and Marketing with AccuLens. And Troy Miller is also on the call here today. He is our VP of Operations, Product Development, and our main engineer. So if many of you haven't used our lab or new to hear about AccuLens, we are located in Colorado, and the Maxim is our flagship design. It was developed out of the University of Colorado, and it has been quite a journey, as all these scleral lenses really have. About 10 years ago is when we started developing the designs to figure out how we could help these patients. And as we all know, we were not really ever fitting the cornea, we were fitting the sclera. So up until now, we've made a lot of modifications over the years on adding scleral toricity and adding different features to make these products work better. But the common thing that the ESP and this new data-driven technology has done is it's kind of given us a direct language to communicate about what's going on. And that is the main benefit, to really help streamline your process as you handle your patient's experience and their clinical outcomes. So essentially, what's going on the sclera at 15 millimeters to 20 millimeters? We never really knew because there was no real mapping out there. I remember 5 years ago and 6 years ago, we were always examining the topographies more than anything. So that's what's fantastic. And we're so excited at AccuLens about the fact that we now know what's the shape out on the sclera, if that's really where we're aligning to make very customized and highly sophisticated products to individualize for each and every patient. So we see now what you see. It's almost like we virtually are coming into your practice. It's a lot of easy to read data outputs that are very sophisticated that the ESP provides, and it makes consultation a lot easier. I'm sure many of you have remembered like trying to describe fluorescein patterns and, well, it looked a little excessive here and shallow there, and it was kind of tight looking at 3 but not at 9, and you get a lens back and perhaps it was better, but you still needed to do one more. So that's what's so fantastic about this technology is we're really streamlining it, and it's a collaboration at a new level. We are making the Eaglet and DirectConnect essentially brings us all together into one place to help that patient and their outcome. So what is this common language? This scan that we were talking about is basically what will be imported to us at AccuLens. So we're seeing real time, basically what you're seeing. It helps us discuss basically options that the patient might benefit from, ideas on the fitting technique, and maybe, you know, some design features that we want to do. But having that now is such a great asset from the manufacturer's point of view. We also have a very highly sophisticated design software that we use at AccuLens, and it's called Focal Points. Very specific, very detailed, and it is basically a designing manufacturing software that can make modifications and design changes at any radius, at any width, and it's very highly customizable to be able to merge essentially with these maps. So as we saw originally with ours on the DirectConnect side, we like to keep it very simple. The ESP is going to have the design parameters embedded for the Maxim and Easy Fit, that first lens fit tab, and it's going to recommend to you which lens to use. That lens then you can use out of your trial set to do an over refraction, and you won't have to input any of that. It'll simply be there. That one form is simple, quick for you to use. It's not a lot of extra data, but just some sort of design changes, notes, if you're doing multifocal, some of the extra things that we like to add at times. You can add that here, and that is all then imported to us on our side. This is where it gets really cool, because now we have like this whole virtual thing that kind of merges together. So your original scan is here, and then the middle box shows basically the 2D CAD design software that we have with Focal Points. Super sophisticated, and we literally can layer them on top of each other, and then we end up coming up with a virtual fluorescein pattern, if you will. We can see maybe that we need to add some toricity out on the sclera, in the design. We can see if we're too shallow somewhere. We can change the sagittal depth if the landing is coming in at the appropriate place, accounting for proper limbal coverage. We can also account for perhaps we need some more vault for settling over 4 hours, things of this nature. So this is everything that moves over to us. We are going to get the data. We're going to layer the Maxim specific design on top of that scan data. And from there, we're going to basically create a completely customized design specific for that patient, which really helps educate patients of the complexity of the craft, how these are completely unique, that I think as a practitioner, it really helps you provide your value as a skilled doctor to provide them something that's really truly unique and going to benefit them and have a great clinical outcome. I would like to default to Troy right here. He likes to really talk about the technical stuff, and he can add in some of his pearls on this piece.
Yeah, just to be a little more clear on how DirectConnect works with our software. Once the ESP file is sent to us within that DirectConnect, we then download that into our CAD system. And what that does is it allows us to have the ability to lay a lens over the surface of that map. And what it does is pinpoints areas that we can provide quadrant-specific landing areas. We can adjust each landing area independently from each other. And secondary to that, it also allows us to, in essence, creates a fluorescein pattern. So when we lay the lens over it, it'll show us via a fluorescein pattern that we need to either increase or decrease the vault, etc. So it's a nice, it's easy to do, and it happens right away. All consultants will do this for every design. So it's a pretty amazing system.
Yeah, and it is. And so here in this example, this patient, Matt, perhaps had a pterygium. So then we can account for how do we handle that? Do we just want to cover it up? Do we want to do quadrant specific? Because I know a lot of practitioners have done a ton of modifications on that kind of eye in the past, trying to make that right for that patient type. So here, that would be one example of how it really helps streamline your process and saving time, chair time for the patients coming back, and overall the patient, the profitability of the fitting. So in a nutshell, Eaglet has done a fantastic job, embedding us all in there. We're super excited that this is the way that the technology has gone. It does make our life a lot easier as far as the manufacturing, and ultimately the patient satisfaction is just terrific. So we're going to basically want those scans. You're going to click that first lens fit. It's going to recommend which lens in our set to use. You're going to place that one on the eye, do your over refraction, fill out the simple form that we have for you to add any kind of additional notes plus some questions that we have, and then hit send. If there's anything further in there, we can certainly email and communicate over the phone over it, but then we'll go ahead and do our magic on our end with focal points and produce a great, if not super close, like a really, really close first lens. And that's the goal, is to make sure that we're moving towards basically creating custom designs on the first lens. So anyway, thank you. If there's questions about AccuLens and the Maxim and how we do it, we'd be happy to answer those. We also host doctors in our laboratory. If any of you would be interested in coming out to Colorado, we can definitely show you how we design our lenses with ESP. Anything else, Troy?
No. Thanks for your time.
Thanks, Alyssa. Thanks, Troy. I want to thank you for that AccuLens review, Maxim review. So next up is going to be Richard Dorer and Jean Blanchard from Blanchard Lenses.
Thank you very much. Good morning. Hope everyone's nice and warm this morning. My name is Richard Dorer. I'm with Blanchard, with Cooper Vision Specialty Eye Care, the Blanchard division, and we're going to talk to you this morning about what we call instrument-driven fitting for the OneFit Med and the OneFit Med Plus, with using the Eaglet Eye Surface Profiler. So really what we want to talk about is using the Eaglet for you're working with the OneFit Med and the OneFit Med Plus lenses. And what those lenses do is they offer total parameter control. You're able to completely customize your fit with the 4 independent fitting zones. You've got your central zone, or your central sag height. You've got your mid peripheral, or what we call the M zone. You've got your limbal zone, and you've got your edge alignment. Those 4 zones you're able to completely control and to work with. And the Eaglet will help you work with that, either if you're going to use it for a first time fit, or if you're going to use it to pull your first trial lens that you're going to work with. There's many different diameters that we have in the OneFit Med family, starting at 15.6, going to 16, 16.4, or in the Med Plus, a 17 millimeter lens. So the Eaglet will also help you choose and work with your diameters of the lenses that you'd like to choose. Now, all of our trial lenses, if you're going to fit this lens and you're going to use a trial lens when you're fitting it, all of our diagnostic lenses have etchings on them to designate the M zone or the mid-peripheral zone, and also the limbal zone. So what that does is that allows you to know where your maximum changes would happen with either of those zones. So, and if you're going to use this, and if you have the benefit of a OCT as well, those etchings will be seen on your OCT much as they would be seen here. So this would be our M zone and our M zone, and this would be our L zone. Now, if you're using an OCT to assist in your fitting as well, the zones where the etchings are also cast a shadow onto the cornea. So that helps you manipulate the lens in each zone to control it how you would like to need those changes, or what changes you would need to make by either increasing that zone or decreasing that zone independently from all the other zones. So we're going to get to how do we get to the Eaglet, or how do we get to the online fitting tools, and then how would we use DirectConnect with the Blanchard OneFit Med or the OneFit Med Plus. So we would go, if you're going to use the information from your Eaglet, you would go to blanchardlab.com. That's going to get you to our homepage for our website. And then on the top right, there's a green button. And you're going to notice there's a lot of red arrows here. We like red arrows. It tells us where to go. People like to tell me where to go all the time. So we're going to click on the green button, and that's going to take us to our product page. And here you have the option to choose either the Med or the Med Plus. So either one of those lens designs you can choose, and that's going to take you to the next step, which is going to take you to the product homepage. There you would click on the fitting tool. So it's really just 3 clicks away and you're at the fitting tool. Once you're at the fitting tool, when you have the information, you would click on the new tool, the Profilometry Assisted Fitting. Once we click on that, it opens this page. These are the profilometers that we work with, and you notice the Eaglet's there, and they're the first ones there. How do we get to transfer the information from the Eaglet DirectConnect to our online fitting tool? Now, you just have to look at this, and we're going to click on this for a little bit more information. So we're going to even help guide the practitioner to the Eaglet Eye Profilometry and how to connect it with the Blanchard fitting tool. So you're going to capture, the first thing is your image capture. You're going to bring that over and look at the results tab on the left. From there, you're going to choose your first lens fit, and then you're going to click calculate, and then it's going to bring it over just as much as Rainier showed you just a few moments ago, and it'll calculate it, and it'll bring the lens information over from the Eaglet into the OneFit Med or the OneFit Med Plus fitting tool. Once you're there, and it's the DirectConnect has brought the information into our online fitting tool, you have 2 choices now. So you can order a projected final lens without having to put a trial lens on. Today with COVID and a lot of people, and I've been on a lot of webinars, people don't want to use trial lenses anymore. I, on the other hand, prefer to fit a trial lens. It makes life easier for me. So if we're going to order a projected trial lens or a projected final lens, this is the information that the Eaglet would have given us. It's going to tell us in this case for the OneFit Med Plus, a 17mm lens with our SAG value of 4,500 and our M and our L values. When you see the M and the L values and you see a minus in front of it, that would mean a minus value in the Med or the Med Plus would bring that part of the lens closer to the eye. And if we use a plus value, like in the L value, that moves it farther away from the eye. That's how we look at this. It also talks to us about our edge. Edge is probably one of the most important things that we deal with, and it's probably one of the most challenging things to get. So in this example, it's going to tell us we're going to use basically a toric haptic. So the flat meridian, which would be the horizontal meridian here, would be plus 75 microns, and our steep meridian, our vertical meridian, would be minus 150 microns. So here we have 225 microns of change for this example. And then it's going to ask us for a lens power, right? So if we're going to put our projected first lens on a patient, we want to, we got to pick a power. How do we do that? So we would click on here and click calculate the lens power. So we have two ways to check your patient's lens power. If the patient is existing corneal or scleral lens patient, put in the base curve of their lens, put in the power, and then click calculate. It's going to give you a projected first lens power. If the patient is a non-wearing patient, if they don't wear any GPs or are currently wearing a scleral lens, it's going to ask for the patient's Ks and refraction, and then you click calculate again, and it gives us a projected lens power. Now that's a pretty handy tool. I mean, you know, a lot of people are trying to figure out how to get a projected first lens on a patient, but it's nice to have them see out of it too, right? At least have a little bit of vision working with that lens. So that's how we would project the projected final lens. Now, if you chose to put a trial lens on, which is what I typically try to do, it's going to give me my recommended trial lens by trial lens parameters, what I would want to do. So in this, it's going to tell us to choose a 4600 SAG, and our standard peripheral is a toric haptic or a toric landing zone on our scleral lenses in the trial set is a flat meridian of +75 and a steep meridian of -125. So 200 microns of difference. Then what we would do is we would click this, transfer this to our fitting tool. This is what our online fitting tool looks like. And it's going to automatically populate these parameters for us. So in line A on our online fitting tool, it's always the lens in situ. It's always the lens that we have on the eye, whether it's a trial lens or if it's a patient's habitual lens. So in this case, it brings over the trial lens. So the 4600 with the toric haptic, our M and our L values are standard, and the trial lens power in that lens is Plano. Then what we would do is we would put in the changes that we would like to make. So we've put our trial lens on, we've taken a look at it. What do we need to do to that lens? So what we would do here is in line B, we would only put what we would want to change in that contact lens or in that scleral lens. So in this, we would want to make our M value at a -150 value or bringing it closer to us, and the L value or the limbal value and move it farther away from the eye. So that's a +100 value. And this is all in microns, okay? And then we would put in our over refraction and we would click calculate. What this now produces is an order that we would want to order, and it also produces a virtual, you know, we're able to see what the changes are to the lens and give us a virtual fit on how we would do it and the changes we would like to make. So this tells us what our sag powers are, our diameters, and our final lens power and our lens thickness. It also gives us something that's pretty important for us, and that's the primary functional sagittal depth. So that's something that the Eaglet performs for us and it gives to us. Now that helps us choose the type of trial lens that we want to use, or it also helps us predict what our final lens would be for the projected final lens. And it's clearly defined with the Eaglet, and we're able to match that eye measurement and then increase the sag height, whatever our desire is for that patient. You know, and then each individual sag value has up to 25 different M values for manipulating the M value. And the M value is the best fit sphere that the Eaglet produces for us. So we're going to fit from the best fit sphere for our mid peripheral value, and that is it. So the Eaglet will produce that for us, and they'll send that information through DirectConnect to our online fitting tool. Now that's how we work with that. And each M value or each sag value can have up to 25 different M values or different best fit sphere values. So one sag can have 25 or more different best fit spheres or base curve values for that. Now, one thing that's very important as well is the capture. Tom mentioned that earlier, that it's easy for the technicians to use and work with. And what we have found when we're working with any of the eye profilometers is that capture is important. The better the capture, the better the lens that we'll design, and the better the information that we'll get back to you. So that's important. So then on the right-hand side, we have a graph of what the lens would look like and the lens the projected changes that you would like to change in the lens. So the black line shows the lens in situ, and the blue line shows the proposed changes to the contact lens or to the scleral lens that you would have. The part on the bottom, it shows us the change in the tear lens. So if we have a decrease in tear lens indicated by a minus value, bringing it closer to the eye, so we would decrease this area of the M zone, and then we gave it fangs. I like to say it that way. So we gave it fangs. So we're gonna increase the limbal zone in this area by 100 microns. Everything we do is in microns, and it all works out very well. So you can see that we didn't change the sag value at all in this, but we did change the mid-peripheral and we changed the limbal zones. Each of these is handled independently from each other. That allows us to customize the fit. The Eaglet allows us the information to work with and the information for you, the practitioner, to use, and then to modify what you would like to use. And then you're able to see the changes in real time before we would manufacture the lens. So if this is something that you would like to order, then you can actually go onto our online order form and continue with the order, putting your account number and any other information, material, or want a dot for the right eye, or any of those types of things. And then it will allow you to come back and design the other eye if that's what you so chose to do. So that's what we have for working with the DirectConnect. The DirectConnect, I've used it in many workshops in practices that have it. And it's, I must say, it's been pretty much dead on. So with our lens designs, it's worked very well. I've been very pleased with that. So there you go. That's what I have. Thank you very much, Tom.
Great to have you, Richard. Thank you so much for that.
Thank you.
And it is a great asset to the practitioner. And then next up, we're going to hear from iPrint Prosthetics, Christine Sant, Naomi Anderson. Tell us about ScanFit.
Thank you, everybody, for spending your time with me this morning. Oh, one of the things that, when I was developing this product is to get to that endpoint faster, but also to get to the endpoint more accurately. I spent a lot of time in medically moderating some of these patient-centric Facebook groups and support groups. And one of the things that I have seen and that I saw in the past was sort of the anguish that patients have every time they go back into the doctor's office and it needs another fit tweak or it needs something else. And, some of these patients have spent, with these complex eyes, have spent, 6, 7, 8 lenses, to get to the end point. And that has a toll both on the patient side and on the doctor side. Their time is worth something, your time is worth something. And personally, my own personal inner happiness is worth something as well. And what I find with that I wanted to get to the point of is where I spend my time with the patient, talking to them about who they are, what they want, their hopes, their dreams, their goals, and less time actually on the design itself, that we can actually work towards the patient's lifestyle and less about the lens design or the lens itself. And that's really where ScanFit Pro comes in, is that brings that opportunity to have these super complex lens designs in your hands, whether it's complex or the patient's complex or the power's complex. We really can put a lot of that into the ScanFit Pro design. And this is actually a lens that's been designed off of the Eaglet data. So we can get these very interesting shapes, whatever it is that you and your patient needs. Naomi Anderson is our point person. She is the contact person and the product manager at ScanFit Pro. She's the one that you would talk to if you had any questions about the product. Now, DirectConnect really changes the paradigm of what we're talking about. You basically take the information, the scan, and it imports right into our software, which would be on your computer. And then you can rotate it around. Everything is in 3D space. So you can take the images, you can take the lens design, rotate it around in 3D space so you can see where any of your problem areas might be or areas that you do want to change on the lens. And so that's where, again, you go down, you choose the ScanFit Pro on the DirectConnect, and that will automatically connect to the ScanFit Pro software, which will be on your computer. Naomi will come in, she will get you all set up, all your defaults, make sure that the program is working for you on your computer, and make sure that you're fully trained in the software so you know how to modify anything that you want. The whole process for the ESP and the ScanFit Pro, once you take your image, the whole process of designing the lens is approximately 3 minutes. And so in my practice, we have my technicians, my ancillary staff does the scanning. And then it really just, my time is spent talking to the patient, and then I can come back and design the lens on my own time when I need to. Patients also really like to see their lens in the 3D space. So, sometimes I do show them the image, or I take a picture of the image to show it to them. It gets them very excited about what they are going to get. If a patient has a bump on their lens, I can then go in and I can show them the bump and say, this is where you've had problems before, or this is where, your eye was getting red, and how this lens is going to help with that. Everything on the ScanFit Pro is customizable. We do recommend that you let the defaults just run for the first set of lenses, at least while you're getting used to the software, because we have worked out a lot of these fitting issues automatically into the software. But with the ESP scans and into the ScanFit Pro, it will automatically detect the limbal points. And so the whole lens design is based off of the limbus. So we have those limbal points. And so, as you know, the limbus is not round, nor is the limbus planar, and that lens will be designed off of those different elevations off of the limbus. We then design the central clearance, the boundary clearance, the limbal clearance, and then we go out to the irregular elevations that are into the periphery of the lens design. It is you'll see this as we go forward. We can determine the central clearance, but our boundary clearance and our limbal clearance can also be elevation specific. So if you have things like pterygiums and things like that, we can actually help with some of that elevation over those lens designs. So it's not just about the elevations that are happening in the periphery, but also at the limbus and inside of the cornea as well.
Hey, Chris, this is Tom. May I interrupt just a minute? Will you explain what you mean by boundary clearance, please?
Yeah, well, we'll go through that as I have some demonstration of the software.
Great, super.
So yeah, that's a great point. So you'll see that in a minute here. The boundary clearance, so the central clearance is really the optic zone, and the boundary clearance is the clearance that you have between the optic zone and the limbus. So it's like the peripheral cornea.
Great, thanks.
Yep. Okay, so we designed this software based off of the thousands and thousands and thousands of impressions that we have in our database, and where we needed to end up with these different the different elevations on the eye. And so the lens design itself is automatically going to vault over any irregularities that are on the surface of the eye itself. We have looked at impressions versus the ESP data, and they're very, very closely aligned. It's remarkable how close the ESP data is to actual impressions. And it gets a wide, in many of these cases, you can get a very extremely wide scan on these patients. And the bigger the scan, the more data that you can get, the bigger the lens, or the more manipulation you can have on the lens. It's important to point out that this is not actually a quad specific design. This is 360 degrees of elevation data that gets incorporated into the lens, and you can manipulate any one of these points. So as you see, as we go through the software, if you want to add a little bit of elevation in one specific spot at the edge, inside the edge, you can make changes in any of those areas. You don't necessarily need to have trial lenses to design this contact lens. You can put one on for power if you want, but you don't need to let the lens settle and go through a series of trial lenses with this. Or you can order off of empirical data if you want to do that as well. So you really are spending most of your chair time with the patient, just talking to them about what their needs are and where they're going on vacation next. Our data right now, we just recently ran the data about our refit rate, and we're about 1.35 lenses per patient. So to get to the end point. It is important to note out though that that includes all of our beta testing. So as we get more and more doctors enrolling in this, and we have our default data toned up and honed in, that refit rate is actually going down. Most of the refits are for power actually, as opposed to actual fit changes on the lens. Okay. So I'm just going to run how this this data works here. Let me just go here. Let's go back here. So right from the DirectConnect, it pulls it right into the ScanFit software and launches it. So the data that you have just pulls in automatically, and you make sure it'll automatically select a right eye or a left eye, depending on the scan that you're working on at that time. And then you will have this in 3D space. You can grab this image and you can rotate it around and really look at it from any direction that you want to look at that 3D scan at this point. The limbus will then automatically be detected. You can again move this around and actually change those limbal points. So you can say, oh, I don't think that one's real, or I want to put it out here. You know, sometimes these really sick eyes that maybe have scars at the limbus, you may want to choose exactly where those limbal data points are, or you could let the software do it. It will then choose your or show you the major and minor diameter. I'll tell you what we're finding is on average, people are at least 1 millimeter different between the horizontal and the vertical diameter. Some people are, you know, two millimeters difference would not be an unusual, 2.5 would not be unusual for these patients. And I think that accounts for some of the fitting issues that we see with round lenses, is that you can get that over vaulting down at the bottom as the lens sinks, and the conge that kind of sucks up to the back of the lens. We just don't see that as much or as often with this design when we do the hyperbolic paraboloid limbal points there. If you choose though, you can force it to be circular, but it doesn't have to be, but that is a choice that you can have. Once you get the limbus defined, you can actually define where you want the optics on the back of the lens. So for example, if you have a very low cone, those optics can actually be moved down so that you have an even tier layer. So you can move the optics around on the lens. If you want to move the optics so that they're over the line of sight, if you have any decentration, you can do that as well. This page here, moving the optics, you will not see that page. It is in the software, it's behind the scenes. You won't automatically see this software, but it is there. And that's just something that you contact Naomi with, and she'll just help you move those optics as you feel you need to move that around. Then from there, we actually can define a lot of clearances. How much central clearance do you want? That's the middle. How much boundary clearance you want? That's at the edge. Where do you want to start the boundary clearance? How much area do you want over the limbus? Do you want a small area? Do you want a big area? Do you want a lot of depth, a little bit of depth? You can make all of those changes. Naomi will actually help you set it up in your software and have it default automatically to what we find works best. But if you want to, and we do recommend that you just let the software run and do its thing. But you can get in there and you can make those changes. So say you get the lens on the eye, some people are super squishy, it settles back more than you expected. You can then go and make those changes on your second lens fit. And so that's from there. So here you can see it all in 3D space. This is the central clearance, boundary clearance, limbal clearance. You can magnify it so you can look at specific little areas. You can look at the periphery there. You can change your edge lift on it. You can see that eye with that hyperbolic paraboloid. This line is the limbus there. And this is an example. She's just going in and changing some of the parameters here. And you can change the diameter of the lens, make it bigger or smaller. And then you'll watch that as the lens changes right before your eyes. So you can change things. Basically, you don't have to decide, oh, how I want to change it. You can change it visually. You can go in and play with the parameters until you get a lens that you like the way that it looks or is going to perform the way you want it to perform. So you don't have to go, oh, do I want this steeper or flatter? You can just literally change numbers till it looks like you want it to look. But I can't really stress enough that to let the defaults just run their data here. Now from this point, you can actually do your front surface page. So you can, at this point, you can play with some parameters it'll default to the center thickness, but you can play with the parameters to change the thickness of your lens. Keep in mind with the scan fit lens, we don't have thin points or junction points on the lens. We keep a profile. So you have an even thickness as it goes across. So you don't get that flexure on the contact lens because you don't have junction points on the lens. You'll see how smooth it is across the front.
Chris,
Yeah.
I got to let you know time.
Okay, we're almost done here. We're almost done. You can go in here and you can calculate your over refractions on the lens. Again, if just like Richard was showing, if you put in your base curve power, it will automatically calculate, or you can do it empirically if you choose to as well. And then from this point, we have other pages that we can go along where you can add a multifocal if you want to add the multifocal lens design. We'll just move across here a little bit. And then at that point, here's the multifocal options. And then you have a bump page where you can go in and you can raise or lower the bumps on the lens. Here we go. Here's a bump page where you can go and say you go, oh, you know what? I know that this eye is really squishy and I want to increase my edge there because I think it's going to dig into this pinguicula. Mind you, it automatically goes up and over the pinguicula, but you can then go in and raise or lower at that particular point. Okay, give it more clearance. How wide do you want it? You can change all of that. How smooth do you want it? You can change that. And then it will apply. And you see it will automatically give you a different bump profile on that. So you can do that on any individual point out in the lens, have total control over that. And then at this point, it will automatically send that file. You just connect, you can then just take that whole file that it's created, which is a DAC file, it's a cut file, and you send that to iPrint. Naomi will review it to make sure that it all looks good, ask you any questions that she might have, and the lens will get manufactured. And so that's really where we're at with iPrint. So if you have any questions, you can contact Naomi and she will help you get the software onto your computer.
That's fantastic. That's fantastic, Chris, and great synopsis. We've come a long way. You know, I've only been doing this 8 years. I think you and Troy and Alyssa and of course Richard and John have been doing this for many, many years. But I tell you, just in the 8 years I've been doing it, it's night and day. So thank you all the labs for participating today and just showing us a little bit of how you use these data.
Tom, before we wind up, there was one question thrown out, and that was I don't know from who, but it was questions about how do you deal with pinguicula and any other abnormalities, irregularities on the sclera. I think all three labs covered it. Troy gets the data from the ESP and takes that into consideration when he cuts the lens. That's at AccuLens. I think Blanchard has it incorporated in their fitting tool, so you can see what they're doing. Am I right, Sean or Richard? Okay, I'm getting a nod from Richard, and obviously Chris just walked you through how they handle it. So they all handle it in slightly different ways, but it can all be taken into consideration. All right, Dr.
Well, one thing. Yeah, good. And to amplify on that, Tom, when you're looking at the map, Rainier was showing you how you can mouse over different areas. So when you see that in the new software, the new ESP software, it actually identifies raised elevations pinguiculae with a little blue circle. You can mouse over that and you can get the exact elevation data, the width, the depth. And so, as you said, with all these labs, they have their own way of dealing with it, but they're not dealing with, oh, it's kind of this big or that big, or, you know, you're not guesstimating. You can actually get real quantitative data over those irregularities. Okay, so anyway, I think we've seen in great detail, again, thank you all for coming, all the labs. The main benefit to this, we measure a much wider zone, not only of the cornea, but also the sclera. And I do want to emphasize to those unfamiliar with Eaglet or just learning about it, it is a topographer as well. So we do get corneal data. So there's no more guesswork about how high, how low. As we talked about, the vinguecula and other irregularities are analyzed quantitatively. And the software is always being upgraded, always being improved. So it is focused on specialty lenses, and not only sclerals like we talked today, but ortho-K, hybrid lenses, which are now getting into quadrant specific skirts, and of course RGPs. And I still use a lot of RGPs in our practice, so we don't want to discount those. And all these labs here today are very, very good also with corneal RGPs, so we shouldn't discount their utility and usefulness. But I can't emphasize enough the benefit of the first lens fit algorithm, because that gives you your best shot at that first lens, less chair time, which is very important to be profitable in this area of your practice, and happier patients are what it's all about. Happier patients are going to grow your practice more than anything else. So the eye surface profiler certainly can help with that.
You know, Tom, I think that one point I wanted to make of what you just said really stuck with me. Patients are really, they're in these chat rooms and they're talking, and they really are expecting less chair time. They really are, you know, that is the way of the future. And I feel like without something like the Eaglet Profiler, people are going to fall behind. They expect, and they're talking to people out there, and they expect the less chair time. And I think that's going to be the way of the future.
There's a lot of chats, but basically everybody's saying thank you, excellent information, great session, et cetera, et cetera. So
really is.
The last slide here, obviously we all hope that you were able to see how intuitive the ESP side of the software is, of the DirectConnect is, and the value of DirectConnect, and these three examples of what goes on the other end of DirectConnect have been fantastic. But the bottom line from Eaglet's standpoint is that I thoroughly believe that profilometry is the wave of the future. The future is now, and to be able to successfully fit any of these lenses, you need a device like the Eye Surface Profiler. So your next step might be to schedule an individualized online demo. You can request a quote. You can let us know what questions went unanswered, and you connect with the lab partners that were here today. I'm going to send an email out to everybody that was here and everybody that registered. They will have all the information they need to connect with the labs, ask questions, get the recorded video, all that good stuff. So I want to thank you all for your attendance this morning, this afternoon, wherever you happen to be. And it was a great session. Thanks to AccuLens, thanks to Blanchard, thanks to iPrint for their side of it. And thanks everybody.
Thank you all for coming and joining
Adios.
us, and Merry Christmas, Happy New Year. Love to everyone.
Thank you. Thanks, Tom.